Hi, these are video notes for 10.7 areas of circles and sectors. So we're going to get through the whole thing here. We're going to be talking about finding the area of a circle, which should be review, and then we'll move into segments and sectors, which should be a little bit of new material. So first things first, we're going to remember what the area formula is for a circle. So it says it here in words, and we'll write it down too. It says the area of a circle is a product of pi and the square of the radius. So a better way to say that is that the area is equal to pi r squared. All right, so if you know the radius, you can find the area. All you need to do is multiply that by pi. Just take note, you cannot put the diameter in there. You have to have the radius. So if they give you a diameter, we need to remember to cut that in half. So just a few warm-up problems with that, then. That's going to be all review. If they gave you a radius, all you need to do is plug in and use the formula pi r squared. So if we know that r is 16, the area of this circle is pi times 16 squared. It doesn't say how we're supposed to round, but a good majority of the time we'll be rounding to the in terms of pi. So what we'll do is just square the 16 and get 256, and then leave pi in our answer. So we are in square inches this time. Remember, pi is just a number, about 3.14, but we're going to leave it in terms of pi this time. They also could give you a diameter all the way across, which means we need to get that r is half of that, which is 11. So we would need to use the radius, not the diameter, to solve this problem. Now that we know that the radius is 11, we have pi r squared. 11 is r. So all we need to do is square the 11 and get 121. In terms of pi, the area of that circle is 121 pi square meters. All right, this one's in words. There's no picture, but that's all right. If the diameter is 16, that means that the radius is 8. They are saying leave it in terms of pi this time. So if r is 8, then we have pi times 8 squared, which means we have 64 pi square inches as our final answer for that. So that's how you find the area, okay, of an entire circle. We're going to talk about sectors and segments still, which get a little bit trickier, but they are just portions of the entire circle. So first things first, the vocab for that, a sector is a region bounded by an arc of the circle and 2 radii. It looks like a pizza slice. So a sector is a chunk of the pie. All right, it's a chunk of the circle. A sector it's just bound by 2 radii and an arc. So what it is it's a fractional part of the area of a circle. If you want to find the area of a sector, it's just a small piece. It's some ratio of the circle. So the area of a sector formed by a 60-degree arc is 60 over 360, or it's 1/6 the total area of the circle. So when we look at finding the area of a sector, we're going to talk about pi r squared still. We also have to know what is the measure of that arc. So similar to how we would have found arc length. If we know this measure, or if we know how many degrees this arc is, AB, we can find the area of the circle because we'll know what the radius is. So this one says the area of a sector of a circle is the product of the ratio. So I'm going to write the formula as it's said in words here. The area of a sector is just equal to how many degrees that arc is. So I'm going to write the measure of arc AB over 360. It's the proportion. How much of the circle are we talking? If it's a semicircle, we're talking half of the circle, so half of the area. Times the area of the circle, but that's pi r squared. So there's our formula for the area of a sector. All right, it's however many degrees out of 360 times that pi r squared, the area of the whole thing. So it's a small piece. It's one slice of the pizza divided or out of the whole thing. Okay. So let's try a few of these then. Let's find the area. So finding the area of each sector, leaving our answer in terms of pi. I'll leave the formula up above here. If I want to know the area of this sector, then I need to know how many degrees the arc is. This time it's 72. and I need to know the radius so that I can find the area. So the area of this sector is going to be 72 out of 360 times whatever the area is, pi times 15 squared. 72 out of 360, that actually just simplifies right down to 1/5. So we're taking 1/5 of the circle this time. 225 is 15 squared. So to leave this in terms of pi, I just need to take the 1/5 and the 225. If I do 1/5 times 225, that's 45. There's still pi as part of the answer. We are in square centimeters. So the whole thing is 225 pi, but just that piece is 45 pi. So let's try another one. So 9 is a radius. 75 degrees is the measure of the arc. So this time the area of the sector is 75 over 360 times pi times 9 squared, since 9 is our radius. So this time I'm taking 75 out of 360 times 81 pi. You can simplify the 75 over 360 a little bit, but you could also just go to the calculator at this part. I'm not going to put the pi in the calculator. Just the 75 over 360 times 81 would give us 16.875. Remember, there's still pi as part of that square inches. So areas of a sector, that's really what we're looking to do. What is the amount of degrees of the arc of the sector? And then multiply that by the area, divided by 360. All right, so moving on, try one more. This one doesn't have a picture, but a circle has a radius of 4. They want to know what is the area of a sector bounded by a 45-degree arc. So you could draw a picture if you want. You don't need to, but we have a circle here. And then we have a sector, something like this. They want to know the area of. This is 45 degrees, and this is 4 inches. All right, so we're finding the area of that sector. So the area is going to be 45 out of 360 times the area of the circle, pi times 4 squared. Okay. So in here, or 45 over 360 just simplifies to 1/8, and then 4 squared is 16, so I have 16 pi there. So they do want the answer in terms of pi, so 1/8 times 16 is going to be 2 pi, and then we have square inches as our result. Okay, so that's how you would find the area of a sector. We have to use that and try even one more thing. That's going to be finding the area of a segment. So we have sectors and segments that we have to know the difference between here. So a segment of a circle. It's a part of a circle bounded by an arc and the segment joining its endpoints. So here's what I mean by that. That's kind of hard to visualize. A sector is going, or a segment is going to look like this third one here. This is a segment. We have just basically a segment going through the circle. The segment of the circle is going to be the area that's made by this segment going through and our arc that's bounding it. Okay, so that's what a segment is. We have to find the area of it, and here's the best way that we have. The area of the sector, which we just showed how to get it, minus the area of the triangle form. So every segment is going to be just a sector with a triangle taken out of it. So we're going to take the area of the sector and get this whole area. Then we're going to get this area and just subtract the two, and we'll be left with what the segment is. So it's kind of a multi-step problem. To find the area of a segment, we have to find the sector and subtract that triangle. So a couple recent things we've learned might help with that. All right, so this one says, what is the area of the shaded segments below? So we're trying to get those yellow areas. It's really 2 steps. So I need to find the area of the sector. If I was looking for the area of the whole thing, that would be all of this. Okay, I can find that red area. And the way we do that is we have to know how many degrees the arc is. 60 out of 360 times pi times the radius, 18 squared. All right, I'm going to move this triangle down a little bit just so that we can rewrite that a little bit with a little bit more space. So the sector is really 1/6 of 324 pi, or that's going to be 54 pi to be exact. That's going to be my sector area. The next thing I need to get is just the triangle. So I'm going to take away this triangle out of that. Okay? So one thing that we just did a few days ago to find the area of the triangle is we took the 18. We know that this would also be 18 since they're both a radius. Now we have side, angle, side. We used this formula last week. 1/2 BC sine of A. I don't know the height of the triangle, but I also don't need to know that since I have that set up for my triangle. So this would be 1/2. B is 18. C sine of A would be 18 sine of 60. So that's still 1/2 base times height. It's just that other formula that we had discovered. If you punch all that in, that's about 140.296. I'll take 3 decimal places just to be a little bit more exact. So then we're ready for the actual answer, the segment. The segment is equal to the sector minus the triangle. All right, so that's going to be 54 pi minus 140.296, because those are the two numbers that we had found. All right, so then the answer, the final answer, when you subtract those, you put it all in your calculator, we get about 29.4. We are in square inches this time. So those are going to be our steps. We're going to try that again, and then I'll have you try one with what time we have left. So let's try this middle one here. All right, again, I'm going to do the triangle work a little bit lower. All right, but this time we have 90, so if I'm finding the whole sector first, we have 90 over 360 times pi r squared. R is 4 this time, so I'm taking 1/4 of 16 pi, which is 4 pi. So that's going to be my sector area. The triangle area, I can actually do 1/2 base times height on this one, because if this is 4, then this is 4, and I actually have a right triangle, so I do know a height. One of the heights is 4, so I can do one area equal to 1/2 4 times 4, or half of 16, which is 8. So last thing here, I need to get the segment. The segment is going to be the same thing each time. It's going to be the sector minus the triangle. So for the sector, we got 4 pi. For the triangle, we got 8. We're just going to subtract those two, and to the nearest tenth, we get 4.6 meters squared. All right, I'll leave this last one to you. Go ahead and pause the video, work on this one, work it all the way through, round to the nearest tenth, and then when you resume the video, you will see the answer pop up. So go ahead and give that a shot right now. Sector minus triangle will give you the segment. So here would be your answer. Hopefully you got 2.5 square meters. So real quickly, I'll walk you through it. The sector was 120 out of 360 times pi times 2 squared, pi r squared. So I just kept that as simple as I could, and so you have 1/3 of 4 pi, just calling that 4/3 pi. The triangle, we don't have a right angle, so we can't use 1/2 base times height, so we do 1/2 BC sine of A, so that would have been 1/2 times 2 times 2 times sine of 120 to get about 1.732. And then when you subtract those two, your 4/3 pi minus 1.732, that gets you to about that 2.5 mark. So that's going to be everything you need to know from circles to sectors to segments. You need to be able to find the area of all three. So now that you've seen the video, you can certainly start trying some on the worksheet. With these, just make sure that you're writing down all the formulas and then you follow each step closely. Okay, pi r squared and then a variation of that for all the rest. Okay, good job.